Hello students, in today's session of current electricity, basic concepts on R equal to rho L upon will be cleared through illustrations. In earlier session, we have gone through all these things which you can review on Sethi shift learn. In this case, illustrations I have taken from JEE main. Also, I would like to say NEET 2025 Freaks paper detailed solution available on website setyshiftlearn.com, which you can have solution on the site. इसके साथ साथ मैं और रिक्वेस्ट करूंगा कि अगर अभी तक आप सेठी शिफ्ट लर्न चैनल को सब्सक्राइब नहीं किया एंड इफ यू लाइक द वीडियो एंड कंटेंट्स प्लीज सब्सक्राइब एंड शेयर विद योर फ्रेंड्स एंड कोलीग्स. Now let's start with concept and questions. Concept regarding resistance of a wire. Resistance of a wire for a given temperature depends on length and inversely proportional to the area. If we combine these proportional to L upon A, that is R equal to rho L upon A, where rho is constant of proportionality and is known as resistivity. It's around ohm meter. Whenever you have to find the resistance, to find resistance, always 2 points or surfaces are defined. Here, in this case, R between P and no. L is taken as parallel to P and Q, and A is taken as perpendicular to P and Q, right? For a given wire, if A is constant, we can use direct formula. If A is not constant, think of integration. Think of integration, right? So, rho is constant for a given wire of material, and it depends on number of free electrons. If it increases, rho increases, right? 1 over rho is conductivity. This is regarding the resistance of a wire at a given temperature, right? Now let's start with the question. Question is, two copper wires of same length have got different diameters. Which wire has greater resistance and which has greater specific resistance? As we know, that R equal to rho L upon A, length upon area, for a given wire of length R proportional to 1 upon A. Means resistance is inversely proportional to area. Resistance is inversely proportional to area. Rho is same as both are of copper. Length is same. All taken into constant of proportionality. Now, therefore, resistance will be more that wire whose cross section of area is small. That is because thicker wire. That is an answer. Second part is greater specific resistance. This will be constant for a given wire at given temperature. Right. Next question. Question is a wire has resistance R. What will its resistance if it starts to double its length? First of all, I will discuss the concept applicable here. As same wire is being stretched, therefore mass will remain same. Therefore, M1 over M2 before and after stretch, that is equal to V1 rho 1 equal to V2 rho 2. This is before, this is after. As rho 1 equal to rho 2 for same material, therefore A1 L1 equal to A2 L2. This comes out to be L1 over L2 equal to A2 over A1. Now, depending on the requirement of the question, we can find the relations. You know, as R equal to rho L upon A, therefore R1 over R2 equal to L1 over L2, A2 over A1. Eliminating area. So this L1 over L2 equal to L1 over L2. This comes out to be R1 over R2 equal to L over L2 whole square. Therefore, R proportional to L square. Similarly, by eliminating length, R proportional to 1 over A square and proportional to R power 4. If same wire is stretched, to R proportional to L square, inversely proportional to A square, inversely proportional to R power 4. Now, according to question, R1 equal to R, R2 we have to find it out, L1 equal to L, L2 equal to 2L. Therefore, R2 over R1 equal to L2 over L1 whole square. That is R2 upon R equal to 4:1. Therefore, R2 equal to 4R. This is the answer. Right? Next question. Question is, Dimension of conductor of specific resistance rho are shown below. Find the resistance of conductor across A, B, C, D, E, F. This is the figure. Concept, applicability and solution. We know R equal to rho L upon A. Here concept is being cleared, how to identify area, how to identify length. Resistance is always determined between two points or surfaces, right? Here, and length is parallel to 2 points or surfaces, and area is perpendicular to 2 points or surfaces. These concepts are applicable here. Therefore, R हमें चाहिए फर्स्ट ऑफ ऑल ए बी सी डी ई एफ, ए बी और सी डी और ई एफ, 3 points. In this case, length will be equal to, in this case, AB. AB के parallel C है, तो length will be C, area will be remaining two sides, that is A into B, A, B. Therefore, resistance RAB will be equal to rho C upon AB. One is this also. Second, RCD. This is parallel to this one. This is B. The length will be B. Length will be equal to B. Length will be equal to B. Area will be equal to A into C. So RCD will be equal to rho B upon AC. REF. REF. In this case, length will be EF के parallel ये A है, length will be A, area will be BC. Therefore, REF will be rho A upon BC. Through this question, concept was cleared how to identify area, how to identify length. Right? Next question. Question is copper wire stress to make it 0.1% longer. What is the percentage change in its resistance? Concept applicable is propagation of error. Propagation of error. Z equal to A की power A, B की power B, Z की power C. dz by z equal to A dA by A plus B dB by B plus C dC by C into this now. Now here, as R proportional to L square, therefore R by R will be equal to twice delta L by L. Percentage change will be, this is delta R by R into 100 equal to twice delta L by L into 100. This is 2 into 0.1%. 0.1%. Therefore, 0.2% is change in its resistance. change in its resistance. Right? Now, I will request, if you are new to my YouTube channel, Sethi Shift Lab, please like and subscribe to my channel, press bell icon to receive updates on concept killing videos. Thank you.